For our next video, we're going to look at comparisons. So instead of parts of a whole, so we're showing the makeup to 100%, what we want to do here is do comparisons. And let's start with the one variable comparison. So we have one field or one variable, and let's say the question is nominal. If the question is nominal, then we can create a bar graph to show how many fall into the different categories, or we can create a column chart to show how many fall into the categories. The difference here is we're looking at number in terms of comparison as opposed to percentages for the parts of the whole. When you have one variable, you can also create what is called a waffle or unit chart. This waffle or unit chart can also be used if we're comparing two variables where both variables are nominal. So let's take a look at a column chart, a bar chart, and our waffle or unit chart. All right, so let's leave this. And just a reminder here, we are working through the workbook from drstephpowers.github.io/BIA, where it says data visualization. All right, so make sure you go into GitHub, you get the Excel files that you need because we're working through the bargain numeric, bargain clean, and CRM clean Excel files. Put them into Google so that you have that to run. All right, so let's go and let's look at a column chart. So we're going to create a column chart, and we can create the column chart here from, let's just go and look at question 1. So in our bargaining survey, question 1 asked about the top priorities in bargaining: improve benefits, improve working conditions, job security, and so on. And we can create a column chart from the uncoded data set. So here this is DF, and let's find the value counts for question 1. So how many people chose each of those categories? And then we're going to sort that index. And in this case, because it's not coded, the order it's going to do it is in alphabetical order. So let's import numpy as np so that we can manipulate the data, and then matplotlib.pyplot as plt for our graphing. So we're going to create this column graph for question 1. So that's why I've called it COL_Q1. It's going to take the value counts from the data frame, the first one that is uncoded, and sort it. Then all we need to do to create our column chart is do .plot. The kind here equals bar. So our horizontal one we used for our stacked had bar H, and then this is just bar. We can create a label for the x-axis. So here we want to call it priorities. And then our y-axis, we can label it count. You can manipulate. I'm first going to remove these so you can see what happens when they're not there. So let's run this. So we can see here the counts allow for fractions. Well, it's counts. Fractions don't make any sense, so we probably want to get rid of the halves. And then the other thing we see is that because these different categories are quite long, if we have it listed like this, it takes up a lot of space. So we might want to angle them just to make our graph a little bit more smaller in terms of how much space it takes up. So if you want to change the tick marks on the y-axis, we do plt.yticks, and we're going to use numpy, and then we're going to create a range from 0 to 25, up to but not including 25 in steps of 5. So that means it's going to start here at 0, and it's going to go up in increments of 5, and it's going to not include 25. So just make sure as you do your range, as we talked about previously, that if you do want it to include 25, then you need it to go maybe say 30 or 27. So you need it to be a number higher than 25 so that 25 is included. So it includes the bottom number, up to but not including the second number, and then you can specify here the increments. For the x-axis here, we're going to take these ticks and we're going to rotate them 45. So if we run that here, you can see we now go 0, 5, 10, 15, 20, not including 25, but in 5 increments. And you can see we have slanted these so that they're a little bit easier to see without taking up too much space. So that is a column chart. And in this case, what we had is we had our one variable, question 1, that was nominal. And then we could see how many people chose each option. Alternatively, you can create a bar graph. Okay, our bar graph here, we can use the coded data for the bar graph. You can use the uncoded data, either way, right? And so I just want to show you, you can do it here with the uncoded. You can do it here with the coded. Actually, let's just do a quick thing here. So if we had changed this instead, I'm just going to switch this to DF2 so you can see what happens when we use the coded data instead for question 1. What we get here is our labels 1, 2, 3, 5. And then what we have to do is we have to, under our X ticks, is we actually have to put the labels in. So if you're going to do it with the coded data, you're going to have to add the labels afterwards. So we'll show you how that works here when we're doing this bar chart below. So let me just switch this here. Okay, so you can see here with this, when we switch this bar graph, see how for Y ticks, I've had to add in the labels. So that's the difference between using the coded and the non-coded for the column chart and the bar chart, is that if you have coded data, you will have to add the labels in. If it is non-coded data for nominal, then it will, as we saw here, oops, it's not DF1, it's just DF. Then it will put the labels in itself, right? So it has that information there. For our bar graph, we still need to have the value counts. So we're going to import numpy and np and import matplotlib.pyplot as plt. Since you just imported those 5 seconds ago with the column chart, you don't need to do them again. But in case you're coming back to this and using this code as example code, then you have this all in one location. So that's why each time we're doing the import, so you don't forget this is what you need for this particular set of data. So we're going to use, and we could call it column, we could call it bar, you can call it whatever you want. We're looking here at question 4A. Question 4A from our coded data set removed the other write-in responses and simply has a 1 for wellness, a 2 for health spending, a 3 for massage, and so on. So in this case, we're going to do DF2, that's the coded data set, find the value counts for question 4A, and then sort them so that they match our coding order, 1, 2, 3, 4, and so on. So what we find here is that no one picked answer 4, which was 1, 2, 3, 1, 2. No one picked chiropractic care. Okay, so it's missing from that data set, and the others have all been coded as 7. To create our bar chart, we use bar H to tell you that it's horizontal. So we're going to take that table that we have here called COL_Q4A. We're going to plot. We're going to use a kind equals bar H. We're going to give the Y label benefit. We're going to give the X label count. So you can see it's flipped from the column chart. But we want the same kind of formatting. So what we're going to do here is instead of changing the Y ticks, we change the X ticks. And we're going to go from 0 up to, but not including 25, in increments of 5. So same as before, but it's the X ticks, not the Y. And then because this is coded, if I just remove this piece here, what you get is you get 1, 2, 3, 5, 6, 7. Well, that's not very helpful for us. So what we're going to need is to translate the code back into what it is. Now, what we want to do is we want to go in order here, 1, 2, 3. So we go back and we see the first one is wellness, the second one is health spending, the third is massage, the fourth is chiropractic care. Our labels need to go in that same order. Notice though that there is no chiropractic care, 1, 2, 3, 5. So don't put it in the labels because then it won't be aligned properly. The other thing to note is that when you are putting the labels, it's not what is 1, what is 2, what is 3. It is order. So this is space 0, space 1, space 2, space 3, space 4, space 5. And so the Y ticks here go from 0 to 5 to indicate what you are replacing in this space and in this space, as opposed to replacing 1, replacing 2. So you'll notice quickly if you try to do 1, 2, 3 that it would have no label here for you. So now when we run this, we can see that it matches here. Wellness and drug are the most important, which is what we see here. Number 1, wellness. Number 6, drug, were the most important to people. So if we have nominal variable, in this case, we have question 4A about what benefit they should prioritize to increase. Then we can create a bar chart or a column chart. And you can create the bar chart or bar graph and column chart with either non-coded data or with coded data. If it is coded, you'll need to add in the labels. So just make sure that you have done sort index and that you are entering them in the order in which you coded them. And then you're marking that the tick marks here are not the values, but the places there. All right, so we looked at, let's just go back to our visual here. All right, so we did column and bar chart for if we have one variable and nominal. If you have one variable that's nominal, you can also do what's called a waffle or unit chart. And a waffle or unit chart can also be used if you have two variables that are both nominal. So let's take a look at that one here. To do a waffle or a unit chart, it is not built into Python, so you will need to install. PyWaffle is the package. So we do a pip install of PyWaffle, and then we need to import it once we have installed it. So we'll take a second, let it install here. All right, we're good to go. Now we're going to import our waffle from PyWaffle. Okay, so capitalization matters when you're naming these packages. So from PyWaffle, import waffle capitalized. And then we also are going to need, because we're graphing, we're going to use matplotlib.pyplot as PLT. Yes, if you just did the previous graph, you already have it running. You don't need to import it again. But if you are only doing our waffle chart here, then it's here so that you don't forget that you need it. So like all of the others, we need value counts. So here, let's look at question 23. That was north, south, east. And what we're going to do is we're going to take our coded data here and find the value counts and then sort it. Okay. So VC value counts for question 23 comes from the coded table. Take the value counts of question 23 and put them in the order in which we've coded them. 1, 2, 3, north, south, east. To do a waffle, there is a particular formatting you have here. So we need our data to be in the form of a dictionary. So remember, that's the curly bracket. There is the variable name. Here we're going to have a variable name north. And then we're going to have VC underscore Q23. So actually, let me just show you what this looks like. VC underscore Q23 is what we created. And here it has our 1, 2, and 3 locations and our numbers 18, 22, 23. So what we're going to do is we're going to say north, that's this one here, and VC underscore question 23, the location is 1. And then for south, VC question 23, our location here is 2. And east, VC question 23, hard bracket 3. So what we're doing here, if we just do this, VC 23, 1, you can see it's just pulling the 18. And if you do VC question 20T, so what it is if I go back, these are the index values. So when we put this hard bracket around 1, it's taking index 1 and giving the number that's right here of 23. And then when we do hard bracket 2, that's the index, it's giving 22. So that's what we're matching here is this 1, 2, 3 to pull this to create this dictionary that says variable north 18, variable south, 22, variable east, 23. Then the rest of this you can leave as you create other waffles, except for in case of how you want it to be laid out. So we're going to plot a figure, open parentheses. The figure class is going to be waffle, so you would leave all that. And then what we're doing here is we are taking rows equals 5 and columns equal 20. The idea is that we're taking kind of 100 bricks, laying them out as 5 rows times 20. And then the values are going to be equal to that dictionary. Values equal data. So that's what you have here. And then we're creating a legend. The legend is going to be located. What this is telling you is that is going to be located to the right of our graph. So when it comes to that B box to anchor, the second number is above and below. The first number is left and right. So notice that it's more than 1. It's telling you that it's to the right here, but that it's in line with the table itself. So if we had made this negative, then it would be to the left. Okay. All right, so let's then run this. And so you can see we have our waffle here, and what this is showing you is that if we're looking at, say, 100 plots, it's comparing how many north responses to south responses to east responses. And so if we look at this here, 3, 6, 7, 3, 6, 7, we have more east responses, and we have the least amount of responses coming from the north. Now, we said that the waffle chart could be used for one variable like we have here, or we could use it for if we have 2 variables that are both nominal. So if we want to do a waffle chart for each location, then what we need to do is we need to create 3 different data tables. One where question 23 equals north, one where question 23 equals south, one where question 23 equals east. We're still going to need the same packages as before because we're still creating a waffle chart. But the difference here is that we are going to take each location, and in this case, we're going to look at question 7. So question 7 is, in the last year, have you received any non-salary compensation? So we have yes, no, and I don't know. And in this case, what we're going to do is we're going to look at how that breaks down at the north location, the south location, and the east location. Now, in order to compare the north, south, and east location, which have a different number of people, we can turn our waffle chart into percentages. And so that's what this is right here, is it says take table A, which is the north location, find the value counts for question 7. So how many people said, if we go back to question 7, how many people said yes, how many people said no, how many people said I don't know, and then sort them. So we have yes is 1, no is 2, and I don't know is 3. But then for each of these, turn it into a percentage. So we're going to take 100. We're going to divide by how many total we have for question 23 or location 1. And then multiply it here. So all we're doing is turning it into a percentage. So let's take here, let's take here. And then what we get is 50-50 here for our question 7. For question, for when the question 23 is south, if we do those same steps, then what we see here is our breakdown is 18% and 81%. And if we're doing this for the east location, then what we see for the east location is that we have people who said yes, 30%. We had people who said no, 65%. And then again, remember the question had an option of I don't know. And only in one location was there any I don't knows to the question about the salary, right? Question was, did you receive any non-salary? So in that location, there's some people who don't know if they had any non-salary compensation. So in order to compare the 3 locations, so nominal data, question 23, north, south, east, and nominal data, question 7, did you receive non-salary compensation? In order to truly compare them, we had to turn them into percentages, because otherwise the little bricks, it would show the difference at the north location and the south location, but because the total number of people responding for north and south weren't the same, it'd be hard at a glance to be able to see if there was really any difference. So in order to do the comparison, we want to have it basically so each location has the same box, and then we're simply looking at the colors and how the colors populate. So to do this, we've done this initial work in order to find these percentages. Now the process is going to be the same as before. We're just creating 3 waffles. So we need 3 dictionaries. The dictionaries have yes, no, and I don't know, and they are populated by index 1 is the yes, index 2 is the no, index 3 is the I don't know, from the 3 tables that we've created here that are now percentages instead of counts. Okay, so for the I don't knows, you could just put 0 for these because there wasn't one. But for the 3rd location, the east location, we're pulling from that index 3. Then, same process as before, plot the figure class is waffle. We're going to do rows and columns 5 by 20 so we can do that direct comparison out of 100. And you really are just repeating this process 3 times. And so this part here, this plot figure, this part is all the same. That's just all formatting. The difference here is we're going to have this plt.gca, and we're going to set this title for north. And here where it says values, we have data 1. So this is going to be the north location data, and we're going to set a title called north. Repeat the process. Plot the same figure, same formatting. The data here is data 2, so it's the data for the south location. And then we're set the title as south. We're going to do all this again, but here the data is data 3 tied to the east location and label it east, and then finally plot all of it. So it looks like a lot of code, but it's the same repetition. You just copy paste and then change it to say data 1, data 2, data 3. We do this, and what we get is we get our 3 locations here. And you can see the north, half said yes, half said no. The south, we can see a small percentage says yes. The rest of them did not receive any non-salary compensation. And the east location has that group that doesn't know. Why is there no little box right here? That's because when we did the calculation and found percentages, there was a fraction of a percentage. The waffle units don't allow for fractions, right? It's a whole box, not a fraction of a box. And so that's why you have this little piece here. When you add the 3 rounded percentages together, it doesn't quite reach the 100%. But by doing this, we can create these waffle charts at a quick glance. We see the breakdown of north and south for question 7. We see the breakdown for the east for question 7. And so at a quick glance, you can see for this nominal, there's a difference. And it's a little bit more interesting to look at than, say, 3 pie charts, right? The challenge, of course, is that it's rounding to whole units because the waffle is made up of little squares.